Let's continue looking at the solutions for the Section 3 pre-check. I know there were a lot of concepts in this particular section. Now we'll look at factoring polynomials. So to factor, recall, is to write an expression as a product. You have to look at what type of polynomial it is and then apply certain procedures for those specific types of polynomials. Number 17 is 4p plus 12. It is a binomial and it has a common factor of 4. If we divide each of those terms by 4, we are left with 4p divided by 4 is p, and 12 divided by 4 is 3. And that's as simplified as we can get it. We cannot rewrite p plus 3 in any other way as a product, so we leave it there. Number 18 is 8a squared minus 4ab plus 6ac minus 3bc. This one has 4 terms, so we use grouping. Grouping, we pair together the first 2 and the last 2 terms and look for common factors between those pairs of terms. 8a squared minus 4ab has a common factor of 4a. Dividing each of those terms by 4a leaves us 2a minus b. 6ac minus 3bc has a common factor of 3c. Dividing those terms by 3c leaves us what? 6ac divided by 3c is 2a. Minus 3bc divided by 3c is minus b. So notice now that the 2a minus b is a factor of each of those remaining terms. We can factor that out as a common factor. And when we divide it out of each of these terms, we get 4a plus 3c. So the factored form is 2a minus b times 4a plus 3c. Remember, we can check our factoring by multiplying it out to see that we get the original polynomial. Number 19 is 4x squared minus 25. That is a binomial that has actually the difference of 2 squares. 4x squared is 2x squared. 25 is 5 squared. Recall that the difference of squares arises from the product of conjugates. And the conjugates consist of what we have to square to get the original term. So that would be 2x minus 5 times 2x plus 5. (81w squared minus 1 is also the difference of squares. 81w squared is 9w squared and 1 is 1 squared. So writing this as the product of conjugates, we get 9w minus 1 times 9w plus 1. (21) is a trinomial, x squared plus 10x plus 16. To factor trinomials, we are trying to find the 2 binomials whose FOIL, or whose product, is this trinomial. Remember that the first 2 terms have to be the first term of the polynomial. So to get x squared, we would have to multiply x times x. The last 2 terms are what gives us the last term of the polynomial. So to get 16, we have to find 2 numbers that multiply to be 16, but the outer and inner terms have to give us this middle coefficient. So we need to find the factors of 16 whose sum is 10. If you think about that, that would be 2 and 8. Doesn't matter the order in which you write the 2 and 8. But to get a positive 16, they have to both be the same sign. To get a positive 10x, but in adding, we have to have both positive numbers. So x plus 2 times x plus 8. 22 is a little bit more complicated polynomial. It is 20p squared plus 19p plus 3. So if we're going to do the guess and check or trial and error here, remember that, again, we have to first find things that multiply to be 20p squared, and then the last terms will be what multiplies to be 3. And then we have to arrange them so that we can get the outer and inner to have a sum of the 19p. So to multiply two things to get 20p squared, there's a lot of choices. We can have 1 and 20, 2 and 10, or 4 and 5. 3, there's only one choice of 3 and 1. So let's try the 4 and 5. And we'll put a 3 and 1. Here I'll put a 1 here and a 3 here. If I do that, I have to check, does the outer and inner give me the 19? So in this case, the outer is 12 plus 5. I don't get 19. But then I have to rearrange these. So let's keep the 4p and 5p alone and interchange the 3 and 1. So now I have a 4 on the outside, a 15 on the inside, and 4 plus 15 does give me 19. So that tells me that's the right combination. All the signs have to be positive. Now, there is a way to do that without having to do a guess and check, and I'll show you that in just a moment. Let me go ahead and get through these problems, and then I'll go back and show you some of these trinomials that are a little bit more involved. Number 23, x squared plus 10x plus 25. We want to look at what are the factors of x squared, which are x and x. The factors of 25 that add up to be 10, and that's going to be 5 and 5. And so x plus 5 times x plus 5, or x plus 5 quantity squared. 24 is y squared minus 20y plus 100. So there we are looking at factors of y squared, or y and y. Factors of 100 that can add up to be negative 20. So that would be a 10 and 10. And to be a negative 20, both signs have to be negative. And again, a last sign being positive means they have to either both be positive or both be negative. Negative times negative is positive 100. Negative 10y and negative 10y is negative 20y, so that checks. So this is really y minus 10 quantity squared. 6x squared minus 5x minus 6. Again, we have a trinomial whose leading coefficient is not 1, so we have to consider what are the factors of 6x squared. We could have 1 and 6 or 2 and 3. I'm just going to start with trying 2x and 3x. Again, we have to find the factors of 6 to be 1 and 6 or 2 and 3. If we try 1 and 6, the outer would be 12 and the inner would be 3, which that does not work. If we put the 6 and the 1 here, the outer is 2 and the inner is 18, which does not give us a 5. So we know that combination of numbers does not work. Let's try 2 and 3 then for factors of 6. We would have 6 and 6, which gives us 12, not 5. And so let's put the 3 and the 2. So then we would get a 4x and a 9x, which will give us a negative 5x if we arrange our signs correctly. A negative 6 on the end means that we have to have different signs. So if you have a difference there, you're going to have different signs, because the only way to get a negative number is to multiply a negative times a positive. And then we need the sum to be a negative 5x. So the larger number has to be negative. And that's not just a larger number, but the larger product. So we have a 4 on the outside and 9 on the inside. So this one needs to be a negative and then a plus. 26 is x cubed minus 27. This is a difference of two cubes. X cubed is x cubed. 27 is 3 cubed. So we need to use this pattern for factoring the difference of cubes. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. And this is one you really just have to memorize. But we would have x minus 3, and then we have to square what's in the position of a, so x squared is x squared. Then we have to do the opposite sign, multiply what's in the position of a and b, so x times 3 is 3x. The last sign is always positive. Squaring the 3 gives us 9. 27 is 2x to the 4th plus 128x. It is a binomial that has a common factor of 2x. We factor that out, and that leaves an x cubed plus 64. So here we have the sum of cubes, because x cubed is x cubed. 64 is 4 cubed. So when we apply the factoring pattern, we have the binomial that consists of what we cubed to get the x cubed and 64, so that's going to be an x plus 4. And then the trinomial, we have to square the first term, so squaring x. We have to take the opposite sign, which is a minus. Multiply x times 4 is 4x. And then the last sign is always positive, and we have to square the 4 to get 16. Number 28 is 12x squared minus 23x plus 10. So here again we have a trinomial whose leading coefficient is not 1, so we have to do some guess and check. Let me show you on this one the other process that I was referring to earlier. Because there's a lot of combinations of 12, right? 1 and 12, 2 and 6, 3 and 4. There's combinations of 10 to be 1 and 10, 2 and 5. So that would be a lot of things to guess and check, which we could do. But there is a more systematic way to factor it, and that is related to this method. You'd say 12 times 10, it's called the AC method. 12 times 10 is 120. And then we need to find the factors of 120 that will add up to be a negative 23. And so don't worry about the signs yet. Let's first find the factors of 120. And there are a lot of them. 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 8, what is that, 8 times 15. In this pair of factors, notice that to get a positive 120, the signs are going to have to both be the same, but to be a negative 23, they're both going to have to be negative. So we could think about each of these being a negative. And the ones that have a sum of negative 23 would be this negative 8 and negative 15. And so the way that you can do this is actually to expand it. This is really the process of doing reverse FOIL. We put in negative 8x and a negative 15x plus 10. So what we're doing in this process is we are actually finding out what are the outer and inner products if I FOILed this out, and I'm replacing that negative 23 with those terms. And then we can apply grouping. So I group together the first two and the last two. Between 12x squared and 8x, there is a common factor of 4x, and that leaves 3x minus 2. Between negative 15x and 10, there's a common factor of a 5. And because we have a negative in front, we have to factor out a negative 5. Negative 15x divided by negative 5 is 3x. 10 divided by negative 5 is negative 2. So here we see this common binomial of 3x minus 2, so that's really 3x minus 2 times 4x minus 5. So it gets you the solution without having to go through a whole lot of guesswork. Let me do one more of those. I know this video is running long. Number 22, let me show you how that could have been done with this method. I could have said 20 times 3 is 60. Looking at the factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, and 6 and 10. I need to find the pair whose sum is positive 19, and that would be the 4 and the 15. And so I would replace the 19 with a plus 4p and plus 15p, and then plus 3. And then group together the first two and the last two. So between 20p squared and 4p, a 4p is common. That leaves a 5p plus 4p divided by 4p is just 1. Between a 15p and 3, a 3 is common. 3 into 15p is 5p, and 3 into 3 is 1. So again, we see that common binomial of 5p plus 1, and the remaining factors would be 4p plus 3. Okay, we'll move on to simplifying radicals and expressing radicals as imaginary numbers. So recall here I had to try to remove a perfect square. The factors of 80, if I think about that, 80 is 1 in 80. 2 and 40, 4 and 20, 5 and 16, and 8 and 10. So in this list, I'm looking for a perfect square as a factor. Notice 4 goes into 20, and 4 is a perfect square, but also 16 is a perfect square. So we always want to use the one with the largest perfect square. So that would be 16 times 5, and the square root of 16 is 4. The square root of 5 can't be simplified any further. 48 is 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. And again, here's one that has the 16, so we would rewrite that as the square root of 16 times 3. It does really rely on your ability to recognize perfect squares, so that would be 4 on the square root of 3. The square root of negative 16, 16 is a perfect square. Remember, we think of that as really 16 times negative 1. And the square root of 16 is 4. The square root of negative 1 is just I. The square root of negative 50, 50 is 25 times 2, so we're going to write that as negative 25 times 2. And the square root of negative 25, the square root of 5 is, the square root of 25 is 5. The square root of negative 1 is I. And then we have the square root of 2. 33 is 3 times the square root of 8, so we rewrite 8 as 4 times 2. Again, that's a perfect square that divides 8. And we write that as 3 times the square root of 4 times the square root of 2. But the square root of 4 is 2. And then times the square root of 2. So 3 times 2 is 6 on the square root of 2. Negative 4 times the square root of 20, we write 20 as 4 times 5. So we really have negative 4 times the square root of 4 times the square root of 5, which is negative 4 times 2 times the square root of 5, or negative 8 times the square root of 5. Okay, a lot of information here. If you have any questions, please don't hesitate to contact me. Thanks.